Hello friends, welcome to my YouTube channel Tech Hub. In the previous video we have seen abstraction and encapsulation. So in this video we will see polymorphism in Java code. Means how we can write the polymorphism concept in Java and how we can implement this one. So before to see the code we will first see the polymorphism definitions. As we already discussed, polymorphism means same name but the behavior is different. Behavior is different. It can be behavior is different according to the input or according to the parameters. And we have taken the example also, like cell phone example we taken. We taken the example of like circle and square. How we will draw the circle, that is different. How we can draw the square, that process is different. But method is draw, that is similar only. In the same way, how when we turn the car, means we can either take left turn or we can take a right turn. It depends on input only, but the method name is turn only. So so this is the example of polymorphism. This is the definition of polymorphism, and these are the three examples of polymorphism that we have given. The first example we already see, and the types of polymorphisms are two types of polymorphism: static and dynamic. Static is nothing but compile time polymorphism, and dynamic is runtime polymorphism. And compile time polymorphism we can achieve through method overloading, and runtime polymorphism we can achieve method overriding. So that also we will see in the code, and that things we will see through the code, and we will take some different example. We will not take any example from this one, we will take some other example. So we have to keep in mind only polymorphism is the same name but the behavior is different according to the input. Okay, so let's see the code. See here if you see, we have created one fan object. And we have started the fan. So how it will start? Because this is a fan, it's a normal fan, so it is started at the speed of 900 round per minute. So it is started. So it will just currently it will print the message, yeah, the fan is started, like that. Suppose if we want to increase the speed of fan, when we are starting it is a normal speed. We want to increase the speed, like in first position, second position or third positions. We have a three states actually for fan. In the same way, so if we started, that is a normal speed 900 round per minute. If we want to increase the speed, then we can give here parameter like start the fan at specific rate. So first one, it is start the fan at normal speed 900 round per minute, and the second one, start the fan at specific rate, specific speed rate. It will start at the specific speed rate. In the similar way, so this is the example of method overloading. This is the method overloading. We will see in the code, in the blueprint of this fan. I will show you that code also. So currently you see this is the example of a method overloading. So what is method overloading? An object define multiple behavior. What is method overloading? Method overloading, an object define multiple behaviors with the same name for possibility called compile time polymorphism. In another word, we can say that compile time polymorphism is achieved within the object by method overloading. So here in this one, if you see, method name is same. Inside this fan object, for this fan object, the behavior is start, that is same, but method behavior name is same, but the action is different. How it is different? If we are not giving any value, then it is starting at normal speed. Normal speed is 900 round per minute rate. If we want to increase the speed, then how we can do that one? We will start that fan at some specific rate, like 1000 we can give, or 1000, 122, like that we can give, 11 we can give, 1100 we can give. So this is the we are giving some specific rate to start the fan. So this is the example of method overloading. So because we are overloading the same method by different parameter, so this is the method overloading, and this is the polymorphism also. Means name is same but the behavior is different according to the parameter. In the same thing, now we have created another object of fan, but the object type is cooler. Now how it is, we will see this also. So this is the example of method overriding. Because you see what is the difference between fan and cooler. Maybe cooler has a more speed, or cooler has a one water pump also, so that also can be started when the cooler is starting. If you left already water pump on, suppose if you left water pump on, the next time when you starting the cooler, automatically the water pump will start. So what is the reason behind that? Fan is also giving you the air, but cooler is also giving you the air, but cooler is giving cool air because water pump is there, but in fan there is no water pump. So what we did, we extended the fan and we designed cooler, because whatever the functionality is there in fan, that is already in cooler, but cooler has some extra feature. So in that case we have written in this way. So we have created here cooler object, and we are starting the cooler. So if you see, if you see here, the cooler here the fan is starting at 900 round per minute, but here the cooler is starting 1200 round per minute. So we have modified the behavior because we are not happy with that one, because our cooler has the more capacity to run at the specific rate. So that's why we implemented in this way, and we modified that behavior of fan. And the start with the specific rate, that is same, we have not touched this also, so it will be starting. So if you see, if I run this code, you will see the output, how it is coming. See, first fan started at normal 900 round per minute speed rate, and fan started at 100 round per minute speed rate. So first what we did, first we started the fan. So this is giving the started fan at normal round 900 round per minute speed. The second one, we have given the parameters here. So it is starting at specific rate, but the method name is same. You see here, our purpose is to see what is polymorphism. So the polymorphism is happening here because the method name is same, but the behavior is different because we are giving different argument. According to the input, now the operation is performing. So now the fan is started at this rate, so it is printing this message: the fan is started at this round per minute, 1100. First time when we fan started, it is starting at the speed 900 round per minute, but the next time when we started the fan, it is starting at specific rate like 1100 round per minute speed rate. And this line just we are printing because I want to differentiate that one, so that's why. So next thing, so this is the example of method overriding, method overloading. This is the example of method overloading. And now the next thing is we are seeing here method overriding. So if you see here, we have defined here fan, but we have defined as cooler. Means a reference variable is fan only, but the object is cooler, because we can give that one because that is a subclass of fan. So we are starting here. Now if you see, here is also fan object only, that is also fan object only, but now why it is starting at a different speed of rate? Even I am not giving the parameter here, I am also not giving the parameter here, but here it is starting at 1200 round per minute, but here it is starting at 900 round per minute. Why? Because I modified the behavior, because we have to see the example also of a method overriding. So this is the method overriding. We are overriding this start method. In that method we have modified the behavior and we have increased the default speed of fan by 1200 round per minute speed rate. And we also started the pump. See here, the cooler water pump started if left on. If we already left that on previous time, then it will start the water pump also, but in the fan there is no water pump, so that's why we extended fan and we created cooler. And this is the same, that is next this method, line number 36, cooler dot start at specific rate. So it will start fan only, because cooler because we have not override that method actually with these parameters. We have not, this is the default implementation that is coming from fan only. So it is saying here fan started at this 1500 round per minute speed. So this is the example of, this one is the example of method overloading, and this one is the example of method overriding. Only this one, sorry. Statement 36 is the example of method overriding, and statement 22 and 25 is the statement 22 and statement 25 are the example of method overloading. Okay, now let's see the class. Actually this is the objects only we created. This is the objects, fan and cooler, but where is the class? Because before to create any object we have to give the class, because we have to give the blueprint. So where is the blueprint? This is the fan blueprint. See here, in this fan we have given one method, start. We have given two methods, not one method. Method name is same here. If you see, this is the default speed. When you call this method, it will print fan started at normal 900 round per minute speed rate. It will start. But when you are giving some specific RPM, specific round per minute, so it will increase the speed. So in this case I am giving here one extra parameter called RPM, but the method name I am keeping as the same only, start only. So it will start at some specific rate. So it was printing here fan started at 1100 round per minute speed rate, because we are calling with this some value. If it is a default one, default start method, then it will print this value, fan started at normal 900 round per minute speed rate. So this is the example of method overloading. We are overloading the same method. method name is same, start. Method name is same, start, but the behavior is different. How it is different? Because it is starting at, it is this rate, it is starting at whatever the specific rate you are giving. So this is the example of method overloading. Next thing, if we see the cooler class, see here, cooler class. So I am extending the cooler class. So what you see here, cooler class, I am extending already fan, and I am making a cooler class. So this is inheritance here. Inheritance will come in the next video. Inheritance is there, that we will see in the next video also. So currently you don't focus on that one. See here, so this is the inheritance that we will see in the next video. So because you just only understand fan object is already there, we want to create cooler from that one. Means because whatever the feature is there in fan, cooler all features have, but cooler has some extra features. So that's why we extended cooler, extended fan, and we made cooler. So this is the inheritance that we will see in the next video. And this is the method, this is the polymorphism. And with what type of polymorphism it is the method overriding. Because how it is method overriding? Because it is overriding the start method. Where is that start method? Start method is already there in this fan class. If you see this one, start method is already there in fan class, that we are overriding here, and we are giving our specific implementation, because we want to modify that behavior, we want to modify that implementation. So that's why we are overriding here, and we are giving our own implementation according to the cooler configuration. So this is the example of polymorphism. What type of polymorphism? This is a runtime polymorphism. This is a runtime polymorphism. This is the example of runtime polymorphism. And the fan class is the example of compile time polymorphism. So I'm just repeating once again. The fan class, fan.java class, is the example of compile time polymorphism, and cooler.java class is the example of runtime polymorphism. Runtime polymorphism also we are calling as a dynamic polymorphism or dynamic binding, and compile time polymorphism we call as a static polymorphism or static binding. So what is the meaning of this static or dynamic? What is the meaning of this static and dynamic? That is, if you have to understand that one, that this statement, line number 22 and line number 33 is enough to understand that one. What is the static polymorphism and dynamic polymorphism? You see, in the line number 22 we are calling fan dot start method. Means from the fan object we are calling start. So it will start from the fan, because when this statement is compiled, because currently this is a Java class, after .java it will become a .class file when you are compiling, after compilation. So compiler will bind this method to the start from fan object only. And here also in line number 33, what compiler will do? Compiler will bind this start method with fan object to execute. But the actual implementation, means the actual execution, will not happen from fan class actually. In the line number 22, compiler will bind with fan object. This start method, compiler will bind with fan object only. It will bind with fan object, and the execution also will happen from fan object. But at line number 33, compiler will bind this start method with fan object, but the execution will happen from cooler object. So that's why this is the runtime polymorphism, means dynamic polymorphism or dynamic binding. And line number 22 is the static polymorphism or static binding or compile time polymorphism. So this was the compile time polymorphism and runtime polymorphism. Fan class is the example of compile time polymorphism. Cooler.java class is the example of runtime polymorphism. And in this main class we are using that fan and cooler object. So that's it. So in the next video we will see what is inheritance. We will see the definition and we will see through code also, and types of inheritance also we will see. So I hope you like the video. If you have any questions, please ask in your chat, ask in the comment section, and we will take out that also. Till that, thanks for watching. Bye bye.